Hi, this is Fred Julien. In this video, I will demonstrate an ACAP called path. And the purpose of path is to capture the path object has moved within the scenes. So as you see, this was me going up and going around the corner. And as soon as the tracking is lost, the object leaves the scene, then the path ACAP will publish that path on MQTT. So below the settings in the menu, you will find the MQTT client settings, where you set the address and the port, and if you're using TLS or not, user and password, and the topic. This is the pre-topic, and then you just connect. Below there are some additional properties that's going to be included in the payload. In this case, it's going to I've set the name to easily more if I have multiple cameras to know which camera is sending the path data. I also can add some information that could be a string, but in this, if you add a JSON location office, that is going to be in a JSON structure. So on the consuming side, I will demonstrate using Node-RED here with a simple flow with a MQTT client and just sending that to debug output. And the MQTT client is going to the same broker, and with a topic, subscription, path, and a plus. That plus is going to be changed to the serial number. So here we see the debug output, and here the topic is going to be path / and the serial number, and that is also going to be duplicated in the payload. So in this case, where if I can use that behavior and adding another MQTT client or subscription here, MQTT subscription, and pasting in the topic, that full topic. And this subscription is only going to get the data from that specific camera. But if I have multiple cameras, I can, with a single subscription, get all the path data. So here we see a bunch of properties. We have a name. Well, I think I changed the name. So the name is actually the front camera. And then we added some information into the path properties. So we get that as a JavaScript object. We have the device with the serial number, and ID is the unique ID of that object. So every object that enters the scene over time is going to have its own unique ID. And then we have the timestamp, which is an epoch and millisecond. And that is the timestamp for when the object entered the scene. We have a delta X, how much the object moved in X direction. And as this is minus 700, so minus would be negative and going, meaning that this object is going left. 70% of from birth to death, 70% of the view. And delta Y is minus 265, meaning it moved up 26.5% of the view. And the total time it spent there was 5.6 seconds, and the total distance was 76% of the view. This can be higher than 100% if the object goes into the scene, moves back and forth, and then leaves the scene. And then we have an array of the sample of places it was. So the first is where the object entered the scene, and then the last one in that array is going to be the last position before leaving the scene. Then we have some the type, the vehicle, or that could be person or other. And then we have class below, which can be, car, truck, bus, motorcycle, face, head. So the consuming side here would be, yes, you can have it as a debug output, but this data structure is also very good that you can just inject that right into a database, which would be the common case where you import the Mongo database. I'll set up the Mongo. I don't have a Mongo database on my local host, but as just for demonstration, where I create a database. I just call it path. It could be a log or whatever. And then the collection is, I'll just call it path. And then, yeah, we're going to save it and only store the message payload, tie that together, and deploy. And yeah, I don't have the Mongo database right there, but if so, this data would automatically just be injected into a database. Thank you for your time, and goodbye.